Let's look at one final trick for working with trigonometric identities. Now this is a trick that you kind of just have to develop a sixth sense for. It's not always clear when you should use this trick, but I don't know, after a while you kind of get a feeling for it. Um, so let's look at this identity. It's not really clear which side it would be better to start with. And I have a sixth sense for this trick, and my sixth sense says, let's start with this stuff on the right, left, sorry, 1 plus sine x over 1 minus sine x. And the reason I want to start with this is because here we have a 1 minus sine x, and if we multiply this, so here's the trick. The trick is, right, we have this Pythagorean identity that says that cosine squared x is equal to 1 minus sine squared x. And we don't have a 1 minus sine squared, we just have 1 minus sine x here. But because of the difference of squares polynomial pattern, we can make 1 minus sine squared x show up in this denominator if we multiply this by 1 plus sine x. So there's the trick. Make a difference of squares show up by multiplying by, in this case, 1 plus sine x. Of course, since we're doing this in the denominator, we have to do it in the numerator as well. Okay, now let's multiply everything out. Now in the denominator, when you multiply this out, you just get 1 minus sine squared x, right? That was the whole point of multiplying by this crazy fraction. In the numerator, we get, well, 1 plus sine x, the whole thing squared. And let's multiply that out. That's 1 plus 2 sine x plus sine squared x. Okay, now in the denominator, 1 minus sine squared x, that's cosine squared x. And this, I think this is promising on this identity because if you look at what we're aiming towards, tangent and secant both have cosines in the denominator. So here we've produced some cosines for our denominator. So that's probably a good sign, probably. So let's see, our numerator is 1 plus 2 sine x plus sine squared x. You know, I multiplied this out, but on second thought, I think it would be better to have it factored. So let's go back to 1 plus sine x squared, like that. And now look, we have a numerator and denominator that are both squared, so we can move that squaring all the way out here. And then the numerator will have 1 plus sine x, and then the denominator will have cosine x. But then we can rework this fraction inside a little bit. This is 1 over cosine x plus sine x over cosine x. But that gives us, inside these parentheses, 1 over cosine x, that's secant x. And sine x over cosine x, that's tangent x. And that's what we wanted. So it worked. This crazy trick worked. Again, it's not, this trick, sometimes it sort of comes out of the blue and it's hard to know when to use it or exactly what to multiply by. So for example, here it's not totally obvious why I didn't multiply the numerator and denominator by 1 minus sine x over 1 minus sine x. That would be another possibility. It all depends on where you wanted to head up, where you wanted to end up. So that's what made me choose the plus in the middle here instead of the minus. Using this trick often is a matter of trial and error. You just try it one way, and if it doesn't work, try it another way, and you know, that goes with most identities. It's not always clear what the correct next step is, so you just have to try things out and see what works.